because if there's two parties on either side of a market and they want to just do a trade, they can't do it directly. Instead, they each have to take all of their value that they want to exchange, they have to chop it up into little chunks, and they have to pass it through the market maker, automated market maker, back and forth. And if they don't, they'll end up just completely tanking the price or shooting the price up to a ridiculous level. So automated market makers are low throughput. They're also really vulnerable to front running. So if someone sees that you're placing a trade to sell some reputation tokens and that transaction sitting in the Ethereum mempool, it hasn't been mined yet, someone can see that and they can go and dump a sell order right in the mempool and place a high gas price, and they can tank the exchange rate of rep for whatever it is you're trading before your trade gets mined, which is really bad. I'm sure you can imagine it's not very fun when you think you're getting one price but you get one that's 20% lower. Another issue is that since the relationship between price and market forces is deterministic, automated market makers are gameable. So Augur and Gnosis, they sort of eventually abandoned the idea of using automated market makers for really moving value. Gnosis did publish an interesting blog post that explained how automated market makers can be really useful for having an on-chain price feed. So you have a smart contract that is able to kind of provide you a feed of an exchange rate directly on the blockchain, which is useful, but ultimately that's not what you really need if you want to have liquid markets that can support lots of volume. So the last class of decentralized exchanges are state channels. And so actually we have Amin here, who's an expert in state channels. He's here today. So if you have questions, go talk to Amin after the talk. State channels are really awesome. Essentially what state channels do is they let you move value off of the blockchain with a counterparty in the channel with you. And you can do a bunch of sort of intermediate state changes, and these are off of the blockchain. They're not being recorded, there's no transactions on the blockchain. You take all of these intermediate state changes, you kind of aggregate them into a single final state, and you kind of dump this final state onto the blockchain, and that you're paying the transaction fee to kind of finalize the state channel and to open it up, but not for anything in between. Another really awesome thing about state channels is that you're not limited by the latency or the throughput of the Ethereum blockchain. So you can do like really low latency trading. You can do a lot of things that you're limited by on the Ethereum blockchain. One of the downsides to state channels is that it requires multiple transactions on the blockchain in order to open the channel and close the channel, ensuring each party in the channel is behaving honestly. It also requires that each party in the channel place a security deposit into the channel to ensure that each party is behaving honestly. And there's also a challenge period. When you're closing the channel, you have to ensure that there's a period of time during which you can challenge your counterparty if they're trying to lie and steal. So as a result, say you just want to do one block trade, you just want to sell some ether, you want to sell some rep, and you just want to do one trade and be done with it. With state channels, it requires multiple on-chain transactions, there's a security deposit, a challenge period. It's kind of a pain. But if you're doing something like high-frequency trading, something where you're doing lots of transactions all the time, state channels are great. Another limitation of state channels is that once you move your funds into the channel and you're sort of isolated from the blockchain, the participants in the channel cannot actually interact with smart contracts. So all of the cool functionality that you might want to access that is located on the Ethereum blockchain, you can't really interact with smart contracts at all. So those are the three sort of high-level classes of decentralized exchanges that exist today. So how does 0x work? 0x uses something called off-chain order relay with on-chain settlement. And what this means is essentially that you generate an order, which is just a package of data, and this package of data specifies the different assets that are going to be traded, the exchange rate that's going to be traded, an expiration time, which is sort of determines how long this order will remain valid or can actually be executed, and a cryptographic signature of all of the parameters specifying the order. And essentially what you do, if you want to place an order on an order book or trade with a counterparty, you generate this data packet specifying all the parameters of the trade that you would like to make. You cryptographically sign it with your private key, and then you broadcast this chunk of data to your counterparty off of the blockchain. So generating this data packet, this order, and broadcasting it to your counterparty, that's all done off of the blockchain, and there's no Ethereum transaction required. Now, the way that you transmit this data packet to your counterparty is not defined. You can